Oh, don't you dare look back, just keep your eyes on me. I said you're holding back. She said shut up and dance with me. This woman is my destiny. She said ooh, shut up and dance with me.
Okay, so for those of you who are new to the whole piano and music thing, this is called a piano, and this particular type is a baby grand. A few facts about a piano. The lowest note on the piano is an A, and it is 227.5 hertz. The highest note is a C, and that has 4,186 hertz. Alright, so moving on to the mechanics of the piano, how it works. Every time you hit a note on the piano, a wooden hammer hits the metal string, and that creates a sound wave. The vibration of the string makes a sound wave. These are called dampers. So once you hit a note and let go, the dampers fall on top of the string and stop the sound. And the longer the string, the lower the sound. So over here, they're very, very long. These are all really low notes. And up here, the strings are much skinnier and are much shorter. Tighter. Also much tighter. You can also see this with a rubber band, which you all will have on your desk right now. When you hold it out like this, and when you play it, you can see that it's much deeper than when you hold it close and hit it like that. It's basically the same thing. The tension changes, so that's what makes it higher or lower.
Oh, don't you dare look back, just keep your eyes on me. I said you're holding back. She said shut up and dance with me. This woman is my destiny. She said ooh, shut up and dance, don't you dare.
Alright, so we're going to start out by counting some beats. I know this is a little elementary, but we're going to do it anyway. So a full note contains 4 whole beats. 1, 2, 3, 4. And a half note contains 2 beats. 1, 2, 3, 4. And a quarter note contains 1 beat each. 1, 2, 3, 4. Now there are other notes. There's 8th notes and there's 32nd notes, but we're not going to get into that right now. But for that was fractions in math. Let's move on. Alright, so let's talk frequency. Frequency is the rate at which a vibration occurs that constitutes a wave. This is basically how often the particles of a sound vibrate. Now, we can say that on a piano, A4 is 440 hertz. That's the unit of frequency. When you multiply the hertz by 2, you get exactly 8 notes higher, which is 880 hertz. Then, when you divide the frequency by 2, you get 8 notes lower, which is 220 hertz. This is an octave. It's 1, 2, 3, 4, 5, 6, 7, 8 notes apart, which, as you could have guessed from the word octave. Sounds that have fundamental frequencies in the ratios of halves, 2/3, and 3/4 sound best when played together. This is called consonance, when sounds have a pleasant, harmonious sound. For example, you can see that in consonance, 3 notes are graphed with their fundamental frequencies. Now at one point, all 3 notes are lined up at the equilibrium point. However, when you get to dissonance, you can see that at no point is both notes lined up at the equilibrium point, which means that the notes are going to be dissonant. Alright, so the next topic is ratios in music. Now ratios are really popular in music because we use them a lot to show chords and notes and octaves. So in an octave, the A5 is referring to the higher A that we just saw, and the A4 is the regular A. So as you can see, it can be written as 2-to-1, that's the ratio, or in 12-to-6 with Pythagorean. Perfect fifth is 5 notes apart, as you might have guessed, which is 1, 2, 3, 4, 5 notes apart. The next thing, perfect fifth is considered the arithmetic mean in an octave. So you would find the mean between those two numbers how you would find the mean between any other two numbers, which is a plus b over 2. So you would take 12 and 6, which is the ratio of the octaves, divided by 2, and that gives you 9. Then you take 9 to the ratio of the octave, which is 6, and then simplify that, which is 3 over 2, or 3-to-2, which is the ratio of a perfect fifth. A perfect fourth is 4 notes apart, like this. Alright, so to find the ratio of a perfect fourth, you use the harmonic mean, which is used by this equation. B is equal to 2ac over a plus c. Remember that in octave the ratio is 12-to-6. I'm sorry that I wrote 6-to-12. Alright, so then you plug in the numbers for this equation, just as you would, and that boils down to 8 to the 6th, which can be simplified as 4-to-3, which is the ratio of a perfect fourth. Piano can also be played with a bunch of different songs, classical, rock, pop, anything. You can play Mozart, which is my favorite, not Sound of Music, some Masterwork Classics, which is also highly recommended by nobody. This is All of Me by John Legend, Love Story by Taylor Swift, Piano Man by Billy Joel, I actually really like this one, and 15 top hits for easy piano. So you can play all of these songs on the piano, and most of them, except for, of course, Beethoven and Mozart, have consonants. Dissonance is when songs they don't sound like you wouldn't think that the notes would be put together in a song, but that's the way it actually is played. For instance, if you were playing these notes, a C and an E, they sound pleasant together. So do C and a G. But these sound terrible, like they sound really bad. And so do these. That sounds pretty bad. And that sounds better, but that is dissonance. And I have my brother here to play a part of the Beethoven's Moonlight Sonata. That sounds pretty terrible, but is actually music, so. Mozart, Billy Joel, and John Legend all have different writing music styles. So see if you can find or listen to hear where there might be dissonance or consonants, or where there's perfect fifths or octaves or anything like that. So.